Okay, so what we have here are proportions, and I need you to keep in mind that a proportion is two equivalent ratios. So what your job is to determine what number can I replace this variable with so that these two ratios are equal to each other. And we have a way of doing this that's very algebraic. And the way it works is I start off wherever my variable is, and I cross multiply with the number diagonally across from it. So if I multiply 6 and x, I get 6x. I'm then going to cross multiply the other way with the 9 and the 4, and the product of 9 and 4 is 36. And I've now created a one-step equation. I'll put an equal sign in the middle here. I'm going to solve that one-step equation. So if I look over here, 6 and x are being multiplied. The opposite of multiplication is division, so I divide by 6. That will cancel the 6's on the left-hand side and leave me with x, which is exactly what I wanted. And then I'm going to come over on the right-hand side. Since it's an equation, whatever you do on one side, I do the same on the other. 36 divided by 6 leaves me with 6. So what that tells me is if I replace x with a 6 up in my original proportion, that the ratio of 6 over 9 is equivalent to 4 over 6. And if I think back to what I know about simplifying fractions, if I simplify 6 over 9, I would get the fraction 2/3. And if I simplify the fraction 4 over 6, I would also get 2/3. So that's a really good way of knowing that I got my answer correct. Let's try one more. In my second one here, I have 2 over 6 is equal to 5 over n. Again, I start wherever my variable is, and I cross multiply. 2 times n leaves me with 2n. I'm then going to cross multiply the other way. 6 times 5, which is 30. And I now have my one-step equation, where my goal is to figure out what is n equal to. Since n and 2 are being multiplied, I do its opposite or its inverse. I divide by 2. That gets rid of the 2 on the left-hand side and leaves me with my variable n. And then I'm going to divide by 2 on the other side. 30 divided by 2 is 15. So that tells me that the ratio of 2 over 6 is equivalent to the ratio of 5 over 15. We can also use proportions to solve some real-world problems. So let's do a quick example. Here I have a word problem that tells me the wait time to ride a roller coaster is 20 minutes when 160 people are in line. At this rate, how long is the wait when 220 people are in line? And what I'm going to do is figure out what two items I'm comparing in this problem. So I'm reading that I'm comparing how many minutes people have to wait and how many people are actually in line to go on that ride. Ooh. So based on that, those are going to be my labels for my proportion. So I'm going to have minutes over people. The cool thing about proportions is that if you decided you wanted to put people in the numerator and minutes in the denominator, you could absolutely do that, as long as you follow your labels throughout the entire problem. So here we go. I'm now going to fill in my first ratio, and it tells me that the wait time is 20 minutes if there's 160 people. So 20 minutes for 160 people. And then they ask us, at this rate, how long is the wait when there are 220 people in line? So how long is the wait becomes x if there are 220 people. And we've now created our proportion, and we're going to solve it the same way that we solved the previous ones. So again, I'm going to start off cross multiplying x by the number that's diagonally across from x. 160 times x gives me 160x. and then we'll cross multiply the other way. So I'm going to do 220 times 20, and that leaves me with 4,400. So 160x is equal to 4,400. And we now have our one-step algebraic equation. Again, my goal is to get x by itself. In order to do that, I'm going to divide both sides of the equation by 160. The 160 will cancel on the left, and we find out that it takes 27.5 minutes to get on the ride if there are 220 people waiting. So I'm going to say x equals 27.5, and my label for this, since the question was how much time, would be minutes.